You've been lied to your entire life. Not maliciously, not deliberately, but lied to nonetheless. Every diagram you've ever seen of the universe, every model of the solar system hanging in your childhood classroom, every illustration in every textbook, they were all beautiful fabrications, necessary simplifications, comfortable deceptions that allowed your mind to grasp something that, in its true form, would break you. The universe does not look like what you think it looks like. Space does not behave like what you imagine. And the edges, oh, the edges, they exist in ways that defy every instinct you possess about where things begin and where they end. Right now, at this very moment, you are hurtling through an infinite cosmic ocean at speeds that would vaporize any human-made vehicle in seconds. You cannot feel it. You cannot sense it. But you are moving through something so vast, so incomprehensibly enormous, that your entire life, everything you've ever known, everyone you've ever loved, every building, every mountain, every continent exists as less than a single pixel in a photograph so large, it would take more atoms than exist in your body just to store the image. And yet, you're going to ask me where it ends. The audacity of that question should terrify you. It should make your heart race. Because the answer, the real answer, is not something human beings were designed to understand. We are creatures of boundaries. We evolved in spaces with walls, with horizons, with clear demarcations between here and there, between inside and outside. Our brains literally cannot process true infinity. Try it right now. Try to imagine infinite space. You can't. What you're imagining is just a very large space. A really, really big room. But infinity? Actual infinity? Your neural architecture collapses before it. So let me start with something that will recalibrate everything you thought you knew. The Big Bang did not bang. Stop. Read that again. Let it sink in. The most famous scientific event in all of human knowledge, the supposed beginning of everything, is named after something that never happened. There was no explosion. There was no sound. There was no center point from which everything erupted outward like fireworks on New Year's Eve. That image in your head, that animation you've seen 1,000 times of a tiny point suddenly blasting outward in all directions. Wrong. Fundamentally, completely, utterly wrong. The Big Bang was not an explosion in space. It was an explosion of space itself. Every point in the universe was the center. Every location was the origin. If you could somehow rewind time 14 billion years and watch the universe collapse backward into its primordial state, you wouldn't see matter rushing toward a single point somewhere out there. You'd see it compressing everywhere, all around you, in every direction simultaneously. The Big Bang happened here. It happened there. It happened in the space between your eyes and this screen. It happened everywhere because, at that moment, everywhere was the same place. Can you feel your mind trying to reject that? That's normal. That's your brain protecting itself from an idea that has no place in the reality you were built to navigate. But here's where it gets worse. Here's where the comfortable lies start to crumble into something far more disturbing. If the Big Bang happened everywhere at once, if there was no center, no edge, no outside from which you could observe it, then what is the universe expanding into? Think about that for a moment. Really think about it. When scientists tell you the universe is expanding, and it is, we can measure it, we can see it happening in real time, Your mind immediately creates an image of a balloon inflating. The balloon gets bigger, occupying more of the space around it. But the universe isn't a balloon. There is no space around it. There is no outside for it to expand into. The universe is all there is. It's not expanding into anything. The fabric of space itself is stretching, creating more distance between points, but it's not filling some pre-existing void. Which means the question, where does space end, is already contaminated with assumptions that make it impossible to answer. You're asking about a boundary, but a boundary is something that separates inside from outside. What is outside space? The question is grammatically correct, but ontologically meaningless. It's like asking what's north of the North Pole or what happened before time began. The words make sense individually, but together they reference something that cannot exist. Yet you can feel it, can't you? That nagging intuition that there must be an edge somewhere. That if you got in a spaceship and flew far enough, fast enough, long enough, you'd eventually hit something. A wall, a barrier, a place where space simply stops. And beyond it, maybe nothing. Maybe something else. Maybe another universe. Maybe a cosmic membrane separating our reality from others. Your intuition is wrong, but it's wrong in the most fascinating way possible. Let me paint you a picture, one that will haunt you. Imagine you're in a spaceship, not a clumsy, fragile human spacecraft, but something impossible. A ship that can travel at any speed, survive any condition, cross any distance. You point it in one direction and you start flying. You pass the moon in seconds. Mars becomes a memory. Jupiter's storms blur past your window. You leave the solar system behind, that cozy collection of planets and asteroids that humanity calls home. You're in interstellar space now, the vast emptiness between stars. Hours pass, then days, years, centuries. You pass other stars, thousands of them, millions. Entire civilizations might rise and fall on planets you streak past without noticing. You're moving so fast that galaxies themselves become signposts. The Milky Way shrinks behind you, its spiral arms contracting into a single point of light, then disappearing entirely. You enter the void between galaxies, true cosmic emptiness, where the distance between anything and anything else is so vast, it makes interstellar space look crowded. You keep going. Millions of years pass. Billions. The universe continues to expand around you. But you're moving faster than expansion. You're outrunning the stretching of space itself. Other galaxies fall away behind you. The density of matter in the universe thins out. You're heading toward the edge now. Surely there must be an edge. Surely, after all this time, after all this distance, you'll reach it. But you won't. You will never reach it. Not because the journey is too long, though it would be. Not because the universe is too big, though it is. You won't reach it because there is no it to reach. Every moment you travel, space continues in front of you, behind you, around you. The universe doesn't have an edge in the way you're imagining. It might be infinite, extending forever in all directions. Or it might be finite but curved in on itself, like the surface of a sphere. Unbounded, but not infinite, allowing you to potentially travel in a straight line and end up back where you started, though you'd never complete the journey before the heat death of the universe. Both possibilities should terrify you equally. An infinite universe means that everything that can happen does happen, somewhere, infinitely many times. There are infinite versions of you reading these words right now. Infinite versions making different choices, living different lives. There are infinite planets where history unfolded differently, where consciousness never emerged, where intelligence evolved into forms we cannot imagine. Infinite Earths where Hitler won. Infinite Earths where humans never existed. Infinite Earths where the laws of physics are just slightly different enough that stars never formed and the universe remained a cold, dark void forever. True infinity doesn't just mean a lot. It means everything. Every possibility, every variation, every nightmare and every dream, played out across an endless cosmic stage with infinite actors in infinite theaters. But a finite universe might be worse, because if the universe is finite, if there's a limited amount of space containing a limited amount of matter, then eventually, trillions upon trillions of years from now, the universe will run out of possibilities. Every particle will have occupied every possible position. Every quantum state will have been exhausted. Time will continue, but nothing will happen. Nothing can happen. There will be no more novelty, no more change, no more anything. Just an eternal frozen wasteland of maximally entropic existence, where the concept of event loses all meaning. These aren't philosophical thought experiments. These are genuine possibilities based on our current understanding of cosmology. One of them is true. Your descendants, if they survive long enough, will live in that reality. But let's go deeper. Let's talk about what space actually is, because you almost certainly have the wrong idea about that too. You think of space as emptiness, a void, a nothing between the somethings. When you look up at the night sky, you see stars. Those are the things that exist. And between them, nothing, empty space. A convenient backdrop against which the drama of matter and energy plays out. Wrong again. Space is not nothing. Space is a thing, a physical thing. It has properties. It can bend, stretch, compress, vibrate. It can carry energy. Einstein showed us this over a century ago, but we still think about space like it's just the absence of stuff. When you drop a ball and it falls to the ground, you don't see invisible fingers reaching up to pull it down. You see empty space. But that empty space is curved by the Earth's mass. The ball isn't being pulled. It's following the straightest possible path through curved space-time. From the ball's perspective, it's moving in a perfectly straight line. It's space itself that's been warped into a shape that makes straight lines look curved to us. This means space can end in ways you haven't considered. It doesn't need a wall or a boundary. Space could simply fold, curve back on itself in dimensions we can't perceive. Imagine a two-dimensional creature living on the surface of a sphere. From its perspective, its universe is a flat plane extending in all directions. It can travel forever without reaching an edge. But from our three-dimensional perspective, we can see that its entire universe is finite, bounded, curved. The creature isn't wrong about its experience. There really is no edge from its perspective. But there's also a sense in which its universe ends at the sphere's surface, even though that end is nowhere within the universe itself. We might be that creature. Our three-dimensional space might be curved in a fourth spatial dimension we cannot perceive. We could travel forever in what we think is a straight line and never reach a boundary. Yet our universe could still be finite, curved, and bounded in ways we cannot directly observe. The edge of space might not be a location, it might be a topology. And then there's the observable universe. Oh, this is where it gets truly disturbing. The observable universe is not the universe. Let me say that again because it's crucial. The observable universe, everything we can see, everything we can detect, everything that light has had time to reach us from since the Big Bang, is just a bubble, a sphere centered on us, with a radius of about 46.5 billion light-years. That's as far as we can see, not because our telescopes aren't powerful enough, but because light from farther away hasn't had time to reach us yet. But the universe beyond that bubble? It's still there. It's just invisible to us. Permanently invisible. And here's the thing that should make your blood run cold. That bubble is shrinking, not in physical size. In terms of what we can ever access or interact with, the universe is expanding, and it's expanding faster the farther away you look. Far enough away, space is expanding faster than light can travel through it. Galaxies beyond a certain distance, the cosmological horizon, are receding from us faster than their light can reach us. We will never see them. We can never visit them. We can never send a signal to them or receive one from them. They exist, but they are forever beyond the reach of causality itself. And every second, more galaxies cross that horizon. Every moment, the observable universe loses territory to expansion. Civilizations we might have one day contacted are being swept beyond the edge of what's reachable. Galaxies our descendants might have visited are being exiled into a realm of permanent inaccessibility. The universe isn't just expanding, it's erasing itself from our potential future, one galaxy cluster at a time. In 1 trillion years, when the last stars burn out and any remaining intelligence looks up at the sky, they will see nothing. No other galaxies, no cosmic microwave background, no evidence that the Big Bang ever happened. All proof of our cosmic origins will have been swept beyond the horizon by expansion. Future cosmologists, if they exist, will look up at a dead, dark sky and conclude, correctly based on their observations, that their galaxy is alone in an infinite empty void. They'll be wrong, but they'll have no way to know it. We live in a special time, a brief cosmic moment when the universe has cooled enough for complexity to emerge, but hasn't yet expanded so much that all evidence of its history has disappeared beyond the horizon. A few trillion years earlier, and the universe would have been too hot for stable matter. A few trillion years later, and it will appear to be nothing but an isolated island in an infinite dark sea. We exist in the narrow window when the universe is comprehensible, unless we don't. Unless our observations are wrong. Unless there's something beyond the horizon that would change everything we think we know. And that brings us to the most disturbing possibility of all. What if the universe does have an edge? A real physical edge? Not in the sense of a boundary we could travel to, but in the sense that the laws of physics themselves break down at some point? What if, beyond a certain distance, space stops being space? What if the equations that describe reality simply stop working? This isn't idle speculation. Our current theories, quantum mechanics and general relativity, are incomplete. We know they're incomplete because they contradict each other at extreme scales. Quantum mechanics governs the very small. General relativity governs the very large. Both theories have been tested to absurd precision, and both work perfectly in their domains. But they can't both be right at the deepest level, because they describe fundamentally incompatible realities. Quantum mechanics says reality is probabilistic, fuzzy, indeterminate until measured. General relativity says space-time is smooth, continuous, deterministic. One of them has to be wrong, or more likely, both are approximations of some deeper theory we haven't discovered yet. And that deeper theory might reveal that space itself is not continuous at the smallest scales. It might be discrete, pixelated, made of tiny indivisible units smaller than anything we can currently measure. The Planck length, about 1.6 x 10 to the 35 meters, might represent a fundamental limit below which the concept of space loses meaning. If space is pixelated, then in a sense it has a resolution, and anything with a resolution has limits. The universe might not extend infinitely far because there aren't infinite pixels. There might be a maximum amount of space, a largest possible distance, beyond which the concept of farther becomes meaningless. The edge of space might not be a place, it might be a computational limit. Reality might be rendered like a video game, with only the parts you can interact with actually existing in any meaningful sense. Or here's an even stranger thought. What if we're already at the edge? What if the observable universe, the bubble of space we can see and interact with, is all there is? What if the reason we can't see beyond the cosmological horizon isn't just because light hasn't reached us yet, but because there's nothing there to see? What if the universe is exactly 46.5 billion light-years in radius, and beyond that, nothing? Not empty space, not dark matter, nothing, the absence of existence itself. You can't disprove this. There's no experiment you could run, no observation you could make that would tell the difference between there's more universe beyond what we can see, but we can't access it, and there's nothing beyond what we can see because that's where reality ends. Both scenarios produce identical observations from our perspective. We're trapped in our cosmic bubble, forever unable to know if there's an ocean beyond the horizon or if the horizon is the edge of the world. Some cosmologists think about this in terms of causality. They argue that if something cannot affect you in any way, if no particle, no force, no information can ever reach you from some distant region, then that region doesn't exist in any meaningful sense. Existence, in this view, is defined by interaction. If two things can never interact, even in principle, even given infinite time, then they don't share a reality. They're in separate universes. By this definition, anything beyond the cosmological horizon is already in another universe. Not another universe in the science fiction sense of a parallel dimension, but simply another region of space that is fundamentally disconnected from ours. And if that's true, then space does have an edge, right there at the horizon. Not a physical wall, but a causal boundary, a point beyond which here and there become meaningless distinctions because no chain of cause and effect can ever connect them. This should bother you. This should keep you up at night, because it means you are trapped, not in a jail cell or a prison, but in a bubble of space-time from which you can never escape, not even in principle. You can never know what's beyond. You can never verify whether there's more universe out there or whether reality simply stops at the edge of what you can see. You're stuck in the only region of space that can ever matter to you, forever separated from potential infinities of existence you can never confirm or deny. And the bubble is shrinking. Every day, more of the universe becomes inaccessible. The edge is closing in. But wait, there's another edge, one much closer, one you've probably never thought about. The edge between something and nothing. Where does an atom end and empty space begin? You'd think this would be simple. The atom has a nucleus made of protons and neutrons, surrounded by electrons in orbital clouds. The electrons are the outermost part of the atom, so wherever they are, that's where the atom ends, right? Wrong, because electrons don't have a location. They're not tiny balls orbiting the nucleus like planets around a sun. They're probability clouds, waves of potential existence that only collapse into something resembling a particle when measured. An electron could be anywhere within its orbital. It could even be found, with very low probability, on the other side of the universe. The probability drops off exponentially with distance, but it never quite reaches zero. Every atom in your body has a non-zero probability of having its electrons on the other side of the galaxy right now. So where does the atom end? It doesn't. Not really. It just fades out probabilistically, getting less and less likely to interact with things the farther you go from the nucleus, but never completely stopping. Every atom is, in a quantum sense, infinite in extent. The universe is not made of discrete objects with clear boundaries. It's made of overlapping fields of probability that mostly concentrate in small regions we call particles, but that technically extend everywhere. You are not contained within your skin. Your quantum fields extend outward, thinning out, becoming less likely to interact with things, but never quite reaching zero. You are smeared across the universe. A very, very small amount of you is everywhere. The boundary between you and not you is not a line. It's a gradient, a slow fade from mostly you to mostly not you, with no clear point where one becomes the other. If atoms don't have edges, if particles are just probability distributions that extend infinitely far, then what makes space space? What is the stuff between the stuff? You've been thinking of space as empty, but we've already established it's not. It's filled with quantum fields. Every point in space has an electromagnetic field value, a gravitational field value, values for the strong and weak nuclear forces, for the Higgs field, for fields we probably haven't discovered yet. These fields are reality. They're not in space. They are space. Space is made of fields, and those fields can have edges. They can end. They can transition from one type of space-time to another. There might be regions of the universe where the quantum fields have different vacuum states, where the laws of physics are literally different, where electrons have different masses or photons behave differently. These regions would be separated by domain walls, boundaries in space where the nature of reality itself changes. We might be in one such domain right now, surrounded by vast regions where physics works differently, regions where stars cannot form, where chemistry is impossible, where consciousness could never emerge. Regions that are, from our perspective, fundamentally uninhabitable. And the boundary between our domain and those others? That's an edge, a real physical edge, where space as we know it ends and something else begins, except we couldn't survive crossing it. The transition would tear apart any structure complex enough to notice the crossing, which means there could be edges all around us, walls between fundamentally different types of reality, and we'd never know, because approaching them would dissolve us back into our constituent particles. The universe might not be uniform. It might be a patchwork of domains, each with its own laws, separated by boundaries we cannot cross and cannot detect unless we're willing to be destroyed by them. Space might end and begin again countless times at scales too large for us to observe, creating an archipelago of habitable zones in a sea of uninhabitable physics. We assume the laws of physics are the same everywhere, because they appear to be the same everywhere we can see. But we can only see our domain, our bubble, our tiny infinitesimal patch of reality. Extrapolating from that to make claims about the entire universe is like a microbe on a grain of sand declaring that it understands the nature of all beaches everywhere. You're beginning to see the problem, aren't you? Every answer about where space ends depends on assumptions. Assumptions about what space is. Assumptions about whether the universe is infinite or finite. Assumptions about whether the laws of physics we observe here apply everywhere. Assumptions about what end even means in a context where boundaries, edges, and limits might not work the way they do in everyday life. Let me make this worse. Let me tell you about the cosmic horizon problem. The universe is approximately 13.8 billion years old. Light travels at a fixed speed, the fastest speed possible. So you might think we can see objects up to 13.8 billion light-years away, right? That's how far light could have traveled since the Big Bang. Wrong. Because the universe has been expanding the whole time. While light was traveling toward us, the space it was traveling through was stretching. This means we can see much farther than 13.8 billion light-years. We can see about 46.5 billion light-years in any direction, giving us an observable universe about 93 billion light-years in diameter. But here's the problem. When we look at opposite sides of the sky, we're looking at regions of the universe that are now about 93 billion light-years apart. And those regions look identical. Same temperature, same density, same distribution of matter. They're in thermal equilibrium. They have the same physical properties as if they'd been in contact, able to exchange energy and information, but they've never been in contact. Light from one has never reached the other. They've never been able to communicate or interact in any way. So how do they know to have the same temperature? How did they coordinate to have the same properties? It's like finding two people on opposite sides of Earth wearing identical custom-made outfits, despite never having met or communicated. The coincidence is too perfect to be coincidence. The leading explanation is inflation. A brief period right after the Big Bang when the universe expanded exponentially fast, much faster than light. During this inflationary epoch, all the regions we can now see were once close together, in thermal contact, able to equilibrate. Then inflation blew them apart so fast that they became causally disconnected. But they retained the properties they had when they were together. This solves the horizon problem, but it creates a more disturbing one. If inflation happened, it probably didn't stop everywhere at once. It might still be happening in some regions. The universe might be vastly, incomprehensibly larger than the observable portion. Inflation might have created not just more space, but infinite space, extending forever in all directions, with our entire observable universe just a tiny bubble where inflation happened to stop early. And if inflation created infinite space, then where does space end? Has a simple answer. It doesn't. Space is infinite, but you will never verify this. You will never see the evidence. The parts of space that would prove infinity are beyond your cosmological horizon, receding faster than light can travel, forever inaccessible to observation or interaction. You'll die not knowing if you live in a finite or infinite universe. Humanity will die not knowing. Every civilization in our galaxy will die not knowing. Because the answer is written in regions of space we can never reach, written in light that will never arrive, encoded in a cosmic truth that is forever beyond the limits of verification. Does that count as an edge? If you can never reach something, never interact with it, never confirm it exists, is it any different from it not existing at all? Is the edge of the observable universe a practical edge even if space extends beyond it? Can you call something real if it can never affect you in any way? Philosophy and physics collide here in uncomfortable ways. The question, where does space end, forces you to ask deeper questions about what you mean by space, and what you mean by end, and what you mean by real, and the answers. The answers might not exist, not because we're too stupid to find them, but because the questions themselves might be asking about things that don't have answers, properties that reality doesn't possess, boundaries that don't exist in any meaningful sense. You wanted to know where space ends. But space might not end, or it might end in ways that make the question meaningless, or it might end at the cosmological horizon, or at domain walls between different physics, or at the Planck scale where space-time itself dissolves into quantum foam, or in a fourth spatial dimension we cannot perceive. Or it might loop back on itself so that end doesn't mean anything in a curved topology. All of these are possible. Some might be true simultaneously. Space might have multiple kinds of edges, some observational, some physical, some topological, some causal. The universe might be so much stranger than you imagined that even the question you're asking needs to be reformulated before it can be answered. And we're only beginning. We've only just started to pick apart the comfortable lies you've been told about reality. We haven't even discussed what's beyond the universe, or whether beyond makes sense. We haven't talked about whether space is emerging from something more fundamental, or whether time has an edge, or what darkness really is, or why there's something rather than nothing. You think you know what space is. You think you understand what it means for something to end, but you don't. No one does. And the deeper we look, the clearer it becomes that the universe is not just stranger than we imagine. It's stranger than we can imagine. Our brains evolved to track prey and avoid predators on the African savanna, are trying to understand a cosmos that operates on principles for which we have no intuition, no experience, no evolutionary preparation. The edge of space is out there somewhere, or it isn't, and both possibilities are equally terrifying. Because if space ends, what's on the other side? And if it doesn't end, how do you process the concept of true infinity when every fiber of your being screams that things must have limits? You're already feeling it, aren't you? That slight vertigo. That sense that the ground beneath your feet is less solid than you thought. That's the feeling of confronting something too large for human comprehension. That's what it feels like when your model of reality starts to crack. Good. You're ready now. Ready to really understand where we are, what we're standing on, and what lies beyond the edges of everything you think exists. Ready to confront the terrifying immensity of cosmic space and the even more terrifying possibility that immensity might be infinite. Ready to discover that the answer to "where does space end?" is so much stranger than you ever imagined. Let's begin. Let's talk about what we know, or rather, what we think we know. Stand outside on a clear night, away from the pollution of city lights, and look up. You'll see stars, thousands of them, scattered across the darkness like diamond dust on black velvet. That's the universe, right? That vast tapestry of lights, that celestial sphere arching overhead. That's what astronomers study. That's what space is. Except that's not the universe. That's not even close to the universe. What you're seeing is a lie, told by light, a comfortable deception that masks the true horror of cosmic scale. Every star you can see, with your naked eye, exists within about 1,000 light years of Earth. 1,000 light years. It sounds impossibly vast. It sounds like forever. But the Milky Way galaxy, just our galaxy, the cosmic neighborhood we call home, is 100,000 light years across. You're seeing 1% of one galaxy, less than 1%. You're seeing the immediate cosmic suburbs, the houses on your street, and thinking you've surveyed the entire planet. But let's pretend you have Superman's eyes. Let's give you vision that can pierce through gas clouds and see across entire galactic distances. Now you can see the whole Milky Way. 200 billion stars spread across that 100,000 light-year disk. Spiral arms wheeling in the darkness, a magnificent Catherine wheel of stellar fire slowly rotating once every 200 million years. Now you can see the universe, right? Wrong again. The Milky Way is one galaxy among 2 trillion galaxies in the observable universe. 2 trillion, each one containing hundreds of billions of stars. The Andromeda Galaxy, our nearest large neighbor, sits 2.5 million light-years away. The light you see from Andromeda left that galaxy before humans existed, before Homo sapiens walked upright, before your ancestors descended from the trees. You're not looking at Andromeda as it is. You're looking at its ghost, a preserved memory of how it looked before humanity began. And Andromeda is close. Cosmically speaking, it's right next door. It's in the same room. The farthest galaxies we can detect with our most powerful telescopes are over 13 billion light-years away. The light from those galaxies has been traveling toward us for longer than the sun has existed, for longer than Earth has existed. That light began its journey when the universe was young and strange and nothing like it is today. Those galaxies, as you see them, are fossils, archaeological artifacts preserved in the amber of space-time. They probably don't even exist anymore, not in the form you're observing. They've had 13 billion years to evolve, to collide with other galaxies, to transform into something entirely different. But you can't see that transformation. You can only see the ancient light, the message in a bottle that took eons to arrive. This is the first uncomfortable truth about space. Everything you observe is history. The universe you see is a patchwork of different eras, all stitched together by the speed of light. You live in a cosmic museum where the exhibits are arranged not by location, but by time. The farther you look, the farther back you see. Distance and time become the same thing. They merge into a single concept that has no equivalent in everyday experience. Light moves at 299,792,458 meters per second, approximately 300,000 kilometers every second. Fast enough to circle Earth 7.5 times in 1 second. Fast enough that, in human terms, it's essentially instantaneous. Click on a lamp and light floods the room immediately. Point a laser at the moon, and the beam reaches it in just over 1 second. But space is not a room. Space is not even a planet or a solar system or a galaxy. Space is so vastly, incomprehensibly enormous that even light, the fastest thing that exists, the cosmic speed limit itself, takes billions of years to cross it. Light itself becomes slow. The fastest possible thing in the universe becomes a crawl when measured against cosmic distances. This creates a profound, disturbing problem that undermines everything you thought you understood about observation and reality. When astronomers tell you the universe is 13.8 billion years old, they're reading that age from light, ancient light, light from the cosmic microwave background, the afterglow of the Big Bang itself, stretched and cooled by expansion until it's now a faint microwave hiss permeating all of space. That light has been traveling for 13.8 billion years. It's the oldest thing we can see. It's a photograph of the infant universe, captured when it was just 380,000 years old, still glowing from the heat of its own birth. But here's what should bother you. That light comes from all directions. You can point a telescope at any patch of sky and detect it. The cosmic microwave background surrounds you. It forms a sphere centered on Earth. Wherever you look, you're looking back to nearly the beginning of time, and every point on that sphere was once close to us, or rather, close to where we are now. During the Big Bang, all those distant points were right here, compressed into a tiny volume of space hotter than any furnace, denser than any material that exists today. The early universe wasn't just hot. It was a cauldron where the rules of physics as you know them didn't apply. Temperature and density so extreme that particles couldn't form stable atoms. Matter and antimatter annihilating each other in cascades of pure energy. Time itself was different. Moving, yes, but moving through a state of existence so alien that if you could somehow visit it, you wouldn't recognize it as the same universe you inhabit now. The early universe was still learning to be a universe, still figuring out how to cool, how to expand, how to allow complexity and structure to emerge from primordial chaos, and it was small. The entire observable universe, everything you can see, everything that light has had time to reach us from, was once compressed into a volume smaller than a marble. All 2 trillion galaxies, all the vast empty spaces between them, all the dark matter and dark energy, all of it squeezed into a space you could hold in your hand. Then it expanded, not exploding outward from a center point, but expanding everywhere simultaneously. Every point moving away from every other point as space itself stretched. And it's still expanding now, right now, this very second. Space is being created between galaxies. New distance is emerging where no distance existed before. The universe is getting bigger, but there's no outside it's expanding into. It's creating the space as it goes. This is where the contradiction emerges. The beautiful, maddening contradiction that has haunted cosmologists for decades. If the universe is expanding, if every galaxy is moving away from every other galaxy, if space itself is stretching and creating more space, then the universe must be getting bigger. And if it's getting bigger, it must have a size. A definite, measurable size, finite, bounded, an enormous sphere, perhaps, but still a sphere with a radius and a volume and, somewhere at the edge, a boundary. But if it has a boundary, what's on the other side? What is it expanding into? You can't have expansion without something to expand into. A balloon inflates into the surrounding air. A city grows by sprawling into the countryside beyond it. To expand is to occupy space that wasn't occupied before. So what space is the universe occupying? The answer, the scientifically correct answer, is that it's not expanding into anything. There is no outside. There is no surrounding space. The universe is all there is, and expansion doesn't mean moving into something else. It means the internal structure of space itself is changing. The distances between objects are increasing, but not because they're moving through space, because space itself is stretching between them. Your brain hates this answer. It should hate this answer, because it's not an answer. It's a word game. It's physics hiding behind semantics. You can say space itself expands until you're blue in the face, but that doesn't resolve the fundamental intuition that expansion requires something to expand into. It just labels the mystery with different words. And this is where we must be honest, brutally honest, about what we know and what we don't know, about where science ends and speculation begins. We know the universe is expanding. We can measure it. We can see galaxies moving away from us. Their light stretched toward the red end of the spectrum by the expansion of space itself. We can calculate how fast they're receding. We can extrapolate backward and estimate when everything was compressed into that tiny, hot, dense state. The math works. The observations confirm it. This is not speculation. This is established, verified, Nobel Prize-winning science. But we don't know if the universe is infinite or finite. We don't know if it has a boundary. We don't know what shape it is. Flat like an endless plane, curved like a sphere, or something stranger still, some topological configuration that has no equivalent in our everyday geometry. We don't know if the laws of physics we observe here apply everywhere, or if they're just local bylaws in our cosmic neighborhood. We don't know what came before the Big Bang, or if before even makes sense when time itself began at that moment. We don't know what the universe is expanding into, or if that question is meaningful. These are not gaps in our knowledge that we'll fill in with better telescopes or smarter theories. These might be questions that don't have answers, limits to what can be known, edges not of space, but of knowability itself. And that's terrifying, because it means the universe might be fundamentally, irreducibly mysterious. It means there might be truths about reality that are forever beyond human comprehension. Not because we're not clever enough, but because those truths exist outside the boundaries of what minds like ours can process. You're standing on a small planet, orbiting an ordinary star in an unremarkable galaxy, looking out at a cosmos that extends far beyond what you can see, governed by laws you only partially understand, containing mysteries you might never solve. And you're asking where it ends, where space itself runs out, where the universe reaches its final limit. The question is simple. The answer, if there is one, will break you. Let me tell you about a man who saw something impossible. Edwin Hubble, 1929, Mount Wilson Observatory. He was studying galaxies, those faint smudges of light that astronomers had only recently confirmed were separate island universes beyond our own Milky Way. And Hubble noticed something that should have been mundane, but turned out to be earth-shattering. The galaxies were moving, all of them, away from us. Not just one or two. Every single galaxy he observed was receding. Their light was shifted toward the red end of the spectrum, stretched by motion, like the dropping pitch of an ambulance siren as it speeds away. And the farther away a galaxy was, the faster it appeared to be fleeing. Distance and velocity were proportional. A neat, linear relationship that held across every measurement. Hubble had discovered cosmic expansion. But here's what he didn't fully grasp at the time, what took decades for cosmologists to truly understand. The galaxies aren't moving through space. Space itself is expanding, carrying the galaxies along like raisins in rising bread dough. The dough expands and the raisins move apart, not because they're racing away from each other, but because the medium between them is growing. This changed everything. If the universe is expanding now, it must have been smaller in the past, denser, hotter. Rewind far enough, and you reach a point where all of space, all of matter, all of energy was compressed into an infinitesimally small volume. A singularity, the Big Bang. But here's the first paradox, the one that should make you deeply uncomfortable. A singularity is not a place. It's not a point in space where the Big Bang happened. It's a moment when space itself didn't exist in any recognizable form. You cannot point to a location and say, "There, that's where it began," because there was no there. The Big Bang happened everywhere simultaneously because, at that moment, everywhere was the same location. Space and time themselves emerged from that singularity. Before it, if before even means anything, there was no stage on which events could occur, no arena for causality, no distance or duration. Think about that. Really think about it. The Big Bang wasn't an event in the universe. It was an event that created the universe. The container and the contents came into existence together. Space didn't expand into a pre-existing void. It brought the void into being as it expanded. Time didn't flow forward from a starting point. It began at that point, and the concept of earlier dissolves into meaninglessness. This is what cosmologists mean when they say the universe has no center. There is no privileged location from which expansion emanates. Every point in space can legitimately claim to be the center because every point originated from the same singularity. You are at the center of the universe. So am I. So is every galaxy, every star, every particle. We're all at the center, which means none of us are. Now let's talk about shape. Not the shape of galaxies or clusters, the shape of space itself, the geometry of the universe. Imagine reality as a vast cosmic film reel, but instead of frames following one after another in time, imagine every frame exists simultaneously. Past, present, future, all laid out in a four-dimensional structure that we call space-time. You experience time as flow because your consciousness moves through this structure, but the structure itself is static, eternal, unchanging. Every moment that has ever occurred or ever will occur already exists. Your birth, your death, every decision you'll make, all of it is already there, frozen in the crystalline structure of space-time like insects in amber. This is the block universe model, and it's what general relativity suggests might be true. Time isn't flowing. You're flowing through time. Or rather, your consciousness is sliding along a particular path through space-time, experiencing one moment after another, creating the illusion of flow. But the moments themselves don't move. They just are. If this is correct, then the question, where does space end, becomes entangled with an even stranger question. When does time end? Because space and time are not separate. They're unified into a single fabric, space-time, that can be curved, twisted, stretched. An edge in space might also be an edge in time, a boundary where not just location, but also causality breaks down. Now, the universe could have one of three basic geometries. It could be flat, extending infinitely far in all directions like an endless plane. It could be positively curved, like the surface of a sphere, finite in size but with no edges, wrapping back on itself so that traveling in a straight line long enough would eventually return you to your starting point. Or it could be negatively curved, like a saddle shape, hyperbolic, also infinite, but with a strange geometry where parallel lines diverge and triangles have angles that sum to less than 180 degrees. We've measured the geometry. We've analyzed the cosmic microwave background, looking for telltale patterns that would reveal the curvature of space-time. And the universe appears to be flat. Perfectly flat, within the limits of our measurement precision. But perfectly flat means infinite. A flat universe extends forever. There is no edge, no boundary, just more space, more galaxies, more structure extending into an endless cosmic expanse. And if that's true, then everything that can happen does happen. Somewhere. Infinite space means infinite possibilities, all realized. Every possible configuration of matter, every possible history, every possible version of you, all of it exists somewhere in the infinite expanse. Unless the measurements are wrong. Unless there's a tiny curvature we haven't detected yet. A slight positive curvature would make the universe finite, enormous, but bounded. And a finite universe means there's a limit, a maximum amount of space, a place where, what? Where space curves back on itself? Where the geometry closes off like the surface of a sphere? Here's the terrifying thing. We can't tell the difference. Not yet. Maybe not ever. If the curvature is small enough, if the universe is large enough, the observable portion we can see would look flat, even if the overall structure is curved. We might live in a finite universe and never know it, because the boundaries lie beyond the cosmic horizon, beyond the limit of what light has had time to reach us from. So we're trapped in uncertainty, living in a cosmos that might be infinite or might be finite, and we cannot determine which. But it gets stranger. Because the universe isn't just expanding, it's accelerating. In 1998, two teams of astronomers studying distant supernovae discovered something that shouldn't have been possible. The expansion of the universe wasn't slowing down, as everyone expected it would, due to gravity pulling everything back together. It was speeding up. Galaxies were accelerating away from each other, driven by some mysterious force that seemed to be pushing space itself apart. They called it dark energy. Not because they understood it, they didn't, and still don't, but because they needed a name for the thing that was ripping the universe apart at its seams. Dark energy comprises about 68% of all the energy in the universe. It's the dominant component of reality, and we have no idea what it is. It might be a property of space itself, a cosmological constant, as Einstein once proposed and then retracted. It might be a dynamic field that changes over time. It might be evidence that our understanding of gravity breaks down at cosmic scales. We don't know. But whatever it is, it's winning. Dark energy is overpowering gravity. The universe will never collapse back on itself. It will expand forever, accelerating, carrying galaxies beyond each other's cosmic horizons until every structure in the universe is isolated, alone in an infinite dark sea. This is the second paradox. The universe might be infinite, but the observable universe, the part we can ever interact with, is finite and shrinking. Every moment, more galaxies cross the boundary into permanent inaccessibility. The cosmos is committing suicide by isolation, fragmenting into causally disconnected regions that can never communicate, never interact, never even know the others exist. In 100 billion years, any civilization that arises will look out at the sky and see one galaxy, their own. Everything else will have been swept beyond the horizon by expansion. They'll have no cosmic microwave background to study, no evidence of the Big Bang, no ability to reconstruct cosmic history. They'll conclude, based on perfect logic and complete observations, that they exist alone in an infinite, eternal, static universe. They'll be wrong, but they'll have no way to discover their error. We live in a special time, a brief window when the universe is old enough for complexity, but young enough that we can still see its origins. A few billion years earlier, and stars wouldn't have formed yet. A few trillion years later, and all evidence of cosmic evolution will have disappeared beyond the horizon. We exist in the narrow slice of cosmic history when the universe is comprehensible. Unless we're wrong about that too. Because here's the third paradox, the one that should haunt you. We can only observe one universe. Our universe. Sample size, 1. Every conclusion we draw about how universes work, every law of physics we discover, every theory we construct, it's all based on a single data point. We have no way to know if our universe is typical or bizarre. No way to tell if the physics we observe is universal or local. No cosmic control group against which to test our hypotheses. What if the laws of physics are different elsewhere? What if there are regions of space, far beyond our horizon, where electrons have different masses, where the speed of light is different, where gravity operates by different rules? What if our universe is just one bubble in an infinite foam of universes, each with its own physics, its own constants, its own rules? This is the multiverse hypothesis, and it's not science fiction. It emerges naturally from our best theories of inflation and quantum mechanics. If inflation happened, and the evidence suggests it did, then it probably didn't stop everywhere at once. It's still happening in some regions, creating new volumes of space, new bubbles where inflation ends and matter forms. Our universe might be one bubble in an eternally inflating multiverse. And those other bubbles? They're beyond our horizon, forever inaccessible. We can never observe them, never visit them, never confirm they exist. Does that make them real? If something can never affect you in any way, if no information can ever reach you from it, if no experiment could ever detect it, is it real? Or is it just metaphysics masquerading as physics? The answer matters, Because if the multiverse exists, then the question, where does space end, becomes, where does our bubble end? And the answer is, at the domain wall, the boundary between our physics and some other physics, a place where the quantum fields transition from one vacuum state to another. Cross that boundary and the laws of nature change. Particles behave differently. Forces have different strengths. Chemistry might be impossible. Life would certainly be impossible. But we can't cross it. We can't even approach it. Because if such boundaries exist, they're far beyond our cosmic horizon, hidden in regions we can never access. We might be surrounded by walls between different types of physics, trapped in a bubble of habitable space floating in an infinite ocean of uninhabitable realities. And we'd never know. We'd live our entire existence. Our species would rise and fall. Civilizations would flourish and die. And none of us would ever discover that we lived in a prison. A beautiful, vast, but ultimately bounded region of space beyond which reality itself becomes alien. This is what keeps cosmologists up at night. Not that we don't know where space ends, but that we might never be able to know. That the answer might exist in a region of space-time forever beyond the reach of observation, sealed off by the speed of light and the acceleration of cosmic expansion. The universe might have edges, real physical edges where space stops being space. But those edges might be invisible to us, not because we lack the technology to detect them, but because they exist outside the boundaries of what is detectable in principle. We're asking a question that might not have an answer, not because the answer doesn't exist, but because it exists somewhere we can never reach. Stop for a moment. Put your hand on your chest. Feel your heartbeat, that rhythmic pulse, that steady drumming, about 70 beats per minute if you're at rest. Each beat pushes blood through 60,000 miles of blood vessels in your body. Each beat is 1 second closer to the last beat, 1 second deeper into a future that's already written in the geometry of space-time. Your heart has beaten approximately 5 billion times if you're around 60 years old. It will beat maybe another billion times if you're lucky. Each beat a countdown. Each pulse a reminder that you are temporary, finite, bounded by a beginning and an end that you cannot escape. Now, think about this. While your heart beats once, light travels 300,000 kilometers. In the time it takes you to read this sentence, about 5 seconds, light has traveled far enough to circle Earth 37 times. In the span of your entire life, light from Earth will travel about 2.5 trillion kilometers. That's the radius of your light cone. The maximum distance any information about your existence can have reached into the cosmos. You are a brief pulse of organized energy in a universe that has existed for 13.8 billion years and will continue for trillions more. A temporary pattern in the chaos. A fleeting arrangement of atoms that, for a cosmically insignificant moment, became complex enough to look up at the stars and ask questions it cannot answer. And everything you are, every memory, every thought, every moment of joy or pain or love or fear exists as electrochemical patterns in 3 pounds of matter inside your skull. Patterns that will dissolve when your heart stops. Patterns that will scatter back into the cosmic background, indistinguishable from everything else, as if you never existed at all. But here's what should terrify you more than death. If the universe is infinite, if space extends forever in all directions, then somewhere out there, impossibly far away, beyond countless horizons, in a region of space you can never reach or observe, there is another you, not a copy, not a clone. You. Exact same atoms in the exact same configuration, experiencing the exact same moment, reading these exact same words, having these exact same thoughts. Because in an infinite universe with a finite number of possible arrangements of particles, every configuration must repeat, not just once, infinitely many times. There are infinite versions of you who made different choices. Infinite versions where you said yes instead of no, where you turned left instead of right, where you became someone unrecognizable. Infinite versions where you died as a child. Infinite versions where you never existed because your parents never met. Infinite versions where Earth never formed, where life never emerged, where consciousness never evolved. Infinity doesn't just mean a lot. It means everything. Every possibility, actualized infinitely many times across infinite space. And if that's true, if the mathematics of cosmic topology really implies this, then you are not unique. You are not special. You are not even singular. You are one instance of a pattern that repeats endlessly, like wallpaper stretching to infinity in all directions. Does that version of you 10p 19, 10t 29, 10 meters away, so far that the number of zeros required to write the distance would fill more books than exist in all libraries on Earth? Does that person matter? Are they real? They're having the same experience you're having right now. The same confusion, the same existential dread, the same desperate need to believe they matter in a cosmos that dwarfs all meaning. Which one is really you? Or are you both equally real? Or is you just a temporary pattern that happens to recur? No more meaningful than a wave in the ocean. Beautiful for a moment, then gone, while the ocean remains. This is the weight of infinity. This is what it means to truly grasp that space might have no end. It's not just about distance. It's about the annihilation of uniqueness, the death of meaning, the realization that in an infinite universe, nothing is special because everything happens infinitely many times. But maybe that's wrong. Maybe the universe is finite. Maybe there's only one of you, unique and irreplaceable, the only instance of this particular configuration of atoms and experiences in all of existence. Is that better? Does that make you feel more significant? Because a finite universe means limits. It means the amount of space is bounded. The number of particles is fixed. The possibilities are constrained. And if the possibilities are constrained, then eventually, trillions upon trillions of years from now, after all stars have died and all black holes have evaporated, the universe will run out of ways to be different. Every possible configuration will have been exhausted. Every quantum state will have been visited. The universe will settle into maximum entropy, a flat, even distribution of energy where nothing can happen because there are no gradients left to drive change. No complexity, no structure, no life, no thought. Just an eternal wasteland of uniformity stretching on forever in time, never changing, never evolving, never ending. That's heat death, the thermodynamic end state of a finite universe. And it's not a distant hypothetical. It's the inevitable conclusion of the laws of physics as we understand them. The universe is running down like a clock, dispersing its useful energy into waste heat, increasing its entropy with every passing second. And there's no way to reverse it, no escape, no reprieve. Your existence, humanity's existence, is a brief, flickering candle in an infinite dark night that will never end. We're living in the universe's youth, the brief period when stars still shine and complexity is still possible. But we're already in the sunset years, already past the peak of cosmic star formation. The universe is getting darker, emptier, colder, and it will continue getting darker and emptier and colder forever. One day, if our descendants survive that long, if they evolve beyond recognition, if they somehow persist for cosmological timescales, they'll watch the last star wink out. They'll witness the final exhalation of light in a universe that's going dark. And after that, darkness, cold, silence, forever. No divine intervention will save them. No miracle will reignite the stars. The laws of physics are indifferent to survival, unconcerned with meaning, blind to suffering. The universe doesn't care if life exists. It doesn't notice when consciousness emerges or when it extinguishes. It just is, following its equations with perfect mathematical precision toward an end state of maximum entropy and minimum meaning. This is the existential weight of cosmology. This is what it means to understand where space might end, or that it might not end at all. Both possibilities lead to the same conclusion. You don't matter, not in the cosmic scheme, not to the universe. Your hopes, your dreams, your loves, your losses. They're all temporary perturbations in quantum fields that will settle back to uniformity and be forgotten by a cosmos that was never paying attention in the first place. And yet, here you are, reading these words, thinking these thoughts, experiencing this moment of awareness that, however briefly, however insignificantly, distinguishes you from the background void. You are a way for the universe to know itself, a pattern of organized complexity that emerged from chaos and became self-aware. You are matter looking at matter and comprehending what it sees. You are the universe experiencing itself subjectively. Atoms arranged in such a way that they can contemplate their own atomic nature. That's not nothing. That might be the most remarkable thing in all of existence. Because as far as we know, as far as we can observe, consciousness is rare. Vanishingly rare. We've searched for signals from other civilizations and found only silence. We've looked at thousands of exoplanets and found none that show signs of life. We might be alone, not just in our galaxy, but in our cosmic horizon. The only minds in 100 billion galaxies. The only observers in a visible universe containing more stars than grains of sand on all Earth's beaches. If we're alone, if consciousness emerged only here, only once, only this one time in this one place, then we're not insignificant. We're everything. We're the universe's only chance to understand itself, the only moment of self-awareness in an otherwise blind cosmos. And if we're not alone, if life is common, but we just haven't found it yet, then consciousness might be the universe's purpose, not in a designed or intentional sense, but as an emergent property, something that naturally arises from the laws of physics given enough time and space. The universe might be structured in such a way that it inevitably produces observers. That complexity and awareness are not accidents, but attractors in the phase space of cosmic evolution. What if the universe needs observers? Not in a mystical sense, but in a quantum mechanical sense. What if consciousness plays a fundamental role in the collapse of wave functions, the crystallization of possibility into actuality? What if reality itself is participatory, requiring minds to observe it, measure it, collapse its quantum superpositions into definite states. Then the question, where does space end, becomes entangled with where does consciousness end? Because if observation is fundamental to reality, then unobserved space might not fully exist. It might remain in quantum superposition, a haze of potential rather than actual. The universe might extend only as far as minds can observe it. The edge of space might be the edge of consciousness. This is cosmic horror. Not the horror of monsters or violence, but the horror of scale, the horror of insignificance, the horror of existing in a cosmos so vast and old and indifferent that your entire civilization could vanish without leaving a trace. The horror of asking questions that have no answers. The horror of understanding just enough to realize how much you cannot understand. You are trapped on a small planet, orbiting an ordinary star, in an unremarkable galaxy, living for a cosmically brief moment, in a universe that might be infinite or might be finite, but either way extends so far beyond your reach that it might as well be infinite. You cannot escape. You cannot explore more than an infinitesimal fraction of what exists. You will die never knowing where space ends, whether we're alone, what happened before the Big Bang, what lies beyond the cosmic horizon. You are imprisoned by the speed of light, trapped in a bubble of causality that's shrinking every moment as expansion carries distant galaxies beyond your reach. You're living in a universe that's committing suicide by isolation, fragmenting into disconnected regions that can never communicate, never reunite, never even know each other existed. And the worst part? The truly unbearable part? You can't stop thinking about it. Now that you know, now that you've glimpsed the scale of cosmic reality, you can't unknow it. It will haunt you. Every time you look up at the night sky, you'll remember that those stars are just the closest ones. That behind them lie billions more. That behind those lie galaxies. That behind those lie incomprehensible voids. That somewhere, impossibly far away, space might end or might not end, and either possibility is equally terrifying. You wanted to know where space ends. But the answer, whatever it is, changes nothing. You're still here, still trapped in this moment, still hurtling toward an end you cannot avoid in a cosmos you cannot escape. The only question that matters now is, what will you do with the brief flicker of time you have? How will you spend these few precious moments of consciousness in a universe that will outlast everything you are by unimaginable eons? The cosmos doesn't care about your answer, but perhaps that's exactly why it matters. Here's what they don't tell you in the textbooks. Here's the secret that cosmologists whisper about in conference hallways, but rarely publish in journals, because it sounds too much like philosophy, too much like mysticism, too much like madness. Space might not exist until you look at it, not metaphorically, not poetically, literally, in the most rigorous quantum mechanical sense possible. The universe, at its deepest level, isn't made of particles or waves or fields. It's made of information, quantum information, bits. And those bits don't specify where things are. They specify probabilities, possibilities, potential locations smeared across space like fog. When you observe a particle, when you measure its position, the wave function collapses. The fog crystallizes. The particle suddenly has a definite location. Before measurement, it was everywhere and nowhere. After measurement, it's here. But here's the thing that should shatter your model of reality. Space itself might work the same way. The holographic principle, one of the most profound discoveries in theoretical physics suggests that all the information in a volume of space can be encoded on the boundary of that volume. A three-dimensional region can be completely described by information on its two-dimensional surface. It's like how a hologram stores a three-dimensional image on a flat piece of film. The interior might not be fundamental. It might be emergent, derived, a projection from the boundary. What if space is a hologram? What if the three-dimensional universe you experience is actually encoded on some distant cosmic boundary? What if depth, distance, volume? What if it's all an illusion created by quantum information on a surface you can never reach? Then the question, where does space end, has a disturbing answer. Space ends at the boundary, the cosmic horizon. Not because there's a wall there, but because that's where the information is actually stored. Everything you think exists out there in the volume of space is actually encoded back there on the surface. You're not in space. You're a pattern of information on the boundary, experiencing the illusion of three-dimensional space. And if observation collapses wave functions, if consciousness plays a role in crystallizing quantum possibilities into classical realities, then unobserved space might not fully exist. It might remain probabilistic, quantum, fuzzy. The universe might only have definite properties where and when it's observed, which means the edge of space is the edge of observation. The boundary between what has been collapsed into actuality and what remains in quantum superposition. Space ends where consciousness ends, where measurement stops, where observation cannot reach. And that boundary is closing in. Every moment, as expansion carries galaxies beyond the cosmic horizon, entire regions of space become unobservable. They cross from the realm of the actual into the realm of the quantum. They stop being definite places and become probability distributions. Not because they're moving away, but because the information about them can no longer reach us. The causal connection breaks. The observation link severs. And without observation, without measurement, without the collapse of wave functions, do they still exist? Maybe the universe is already dead. Maybe the heat death happened trillions of years ago in some reference frame, and what we're experiencing now is just a quantum echo, a probabilistic afterimage. The universe's wave function slowly decohering, spreading out across the multiverse of possibilities, with our consciousness riding one branch of that wave function toward dissolution. Maybe every time you make a choice, the universe splits, not into separate physical worlds, but into separate branches of the quantum wave function. Every decision point creates a superposition, and the you who experiences this moment is just one thread in an incomprehensibly vast tapestry of possibilities, all existing simultaneously in the quantum foam, all equally real, all observing slightly different versions of reality. Space doesn't end at a location. It ends at every quantum decision point where one universe becomes many, where certainty dissolves into probability, where the definite becomes indefinite. Look up at the night sky. Those stars, they're not where you see them. They're where they were years or centuries or millennia ago when their light began its journey. You're not seeing space as it is. You're seeing a probability distribution of where space might have been, collapsed into a definite image by your observation. The universe you perceive is already a ghost, an echo of something that might not exist anymore in any definite sense. And somewhere out there, beyond the cosmic horizon, beyond the reach of light and causality and observation, there might be another you, or there might be nothing. Or there might be something so strange that the concepts of something and nothing break down entirely. The edge of space is wherever reality stops being definite and starts being probabilistic. And that edge is everywhere. Right here, right now. At the quantum level, reality is constantly collapsing and reforming, creating and destroying space itself in a foam of possibility. You are not in the universe. You are the universe. A brief moment when quantum information organizes itself into a pattern complex, enough to observe itself. And when you stop observing, when your consciousness ends, your universe ends with it. Space ends where you end. And you end everywhere. So where does space end? Maybe it doesn't. Maybe it loops back on itself in dimensions you cannot perceive. Maybe it fragments into infinite bubbles, each with its own physics, its own fate. Maybe it ends at the cosmic horizon where observation fails and quantum probability takes over. Maybe it ends with you, when your consciousness stops collapsing wave, functions and reality dissolves back into superposition. We've traveled from the comfortable lies of childhood diagrams to the disturbing truth of cosmic geometry. From the Big Bang that didn't bang to the edge that might not exist. From infinite repetitions of yourself to the heat death of everything. From quantum foam to holographic boundaries. And we still don't know. We may never know. But here's the final question. The one that should haunt you forever. If space ends where consciousness ends, and consciousness is observing space, then what happens when nothing is left to observe? Does the universe blink out like a candle? Or does it continue unobserved in quantum limbo, neither existing nor not existing until something, somewhere, measures it again? The universe may have no end, but maybe neither do you.